Okay, students, welcome once again. So we were doing some examples based on matrices and their addition, right? So in continuation, let us take another case. And I have told you in the very beginning that we will use the concept of equality of two matrices many times during the solutions of the various questions, right? So this example is based on the equality of two matrices and then see how the equality of two matrices is helpful for finding out the solutions of the various questions or various matrices. Find the values of x and y if this matrix 2x plus 1, 3y, 0, y square minus 5y, this is equals to x plus 3, y square plus 2, 0 and minus 6, right? See what we have given here. We have given here the matrix, this first matrix, this is equals to this matrix. So look at matrix 1. This is a matrix of order 2 by 2, right? It contains 2 rows and 2 columns. And matrix 2 is also a matrix of order 2 by 2. First, try to understand the structure of these two matrices. So these two matrices are of the same order, and the order of both of these two matrices is 2 by 2, or they are of order 2 matrices because they all are square, right? And what is given to you? It is given that the matrix 1 is equals to matrix 2. And we know the two matrices are equal if, number 1, they are of the same order, and number 2, their corresponding elements must be equal. This is the basic requirement or prerequisite condition for equality of two matrices. Clear? Two matrices are equal if, number 1, they are of the same order, and number 2, their corresponding elements are also equal. I have already explained very clearly in detail about the corresponding elements, right? Now let us come to the solution of this question. See what we have given. We have actually given here the matrix. See, this matrix is equals to, this is a matrix 2x plus 1, and this is 0, this is 3y, and this is y square minus 5y. This matrix is equals to x plus 3, 0, y square plus 2, and minus 6, right? So these two matrices are equal. Of course, we have checked that they are of the same order. So condition 1 is satisfied. And condition 2 says their corresponding elements are equal. And what are the corresponding elements? Corresponding element means the first element of the first row and first column of the first matrix should be equals to the first element of the first row and first column of the second matrix, and then so on. So what is this? 2x plus 1 is the first element of the first row and first column of the first matrix. It should be equals to x plus 3 because x plus 3 is the first element of the first row and first column in matrix 2, right? Now 3y. 3y is the second element of the first row and second column of the first matrix. So it should be equals to y square plus 2 because y square is the second element of the first row in the second column of the second matrix. This is the meaning of corresponding elements. So this is the first element of the second row. So it should be equals to first element of the second row. This is the second element of the second row. It should be equals to second element of the second row. Understand? Do you understand the meaning of corresponding elements? Now they should be equal. Now what we have written, by equality of two matrices, the corresponding elements should be equal. So what we will get? We get 2x plus 1. This is equals to x plus 3. Equation number 1, right? This should be equals to this. Second is 3y is equals to y square plus 2. This should be equals to this, right? 0 is always equals to 0. It is of no use. Then this should be equals to this, that is y square minus 5y, this is equals to minus 6. So we are having these three equations, right? And from these three equations, we have to find out the values of x and y. See, from equation 1, twice x plus 1 is equals to x plus 3. So transfer this x from here. What we will get? X is equals to 3 minus 1, that is 2. So x is coming out to be 2 from equation 1, right? Now there are two equations for y. Equation 1 is what? See, y square minus 3y plus 2, right? This is equals to 0. Now find out its factor. Factor means what? Find out the factors of 2 such that their product should be equals to 2. So minus 1 and minus 2, the product of these two numbers is 2, and their sum, that is minus 3. Minus 3 you will get minus 1 minus 2, right? So this can be written as y square minus 2y minus y plus 2, this is equals to 0, right? To take y common from here, what is left? Y minus 2. Take minus 1 common from here, you will get y minus 2, this is equals to 0. So this implies y minus 1 and y minus 2, this is equals to 0. So from here what we get? Y is equals to 1 and 2. We are getting two values of y from equation number 2, right? Now take the equation number, this is equation number 2. Now take equation number 3. Equation number 3 is what? Y square minus 5y, y square minus 5y, transfer this 6, plus 6 is equals to 0 because we will transfer 6 from right to left, so we will get here 6. So again here find out the factors of 6 so that its sum should be equals to minus 5. So see, 6 can be written as minus 2 into minus 3, and minus 5 is what? Minus 2 minus 3, you will get 5, right? Okay. So this can be written as y square minus 3y minus 2y plus 6, this is equals to 0. Take y common, we will get here y minus 3. Take minus 2 common, we will get here y minus 3. This is equals to 0. So what you will get? Y minus 2 and y minus 3 is equals to 0. So this implies what? Y is 2 and 3, right? So what values we actually obtain? Clarify from here. X is getting only one value, that is 2. Y is having 1, 2 and 3. See? The values of x and y are x is 2 and y is getting 1, 2, 3. So y here is having 3 values. So we will have to check which value is satisfied by the given matrix equation this, right? So what we will do first? First take x is equals to 2 and y is equals to 1, case 1. Case 2, x is equals to 2, y is equals to 2. And case 3, x is equals to 2 and y is equals to 3. Naturally, clear? These are the three possibilities because x is having only one value and y is having 3 value. So if x is 2, y may be 1. X is 2, y may be 2. X is 2, y may be 3. Now we will check out of these three possibilities which one is true. Now it's an exercise for you pupil. If you will put x is equals to 1 and y is equals to 1 in our equation this is our equation. This first value will not be satisfied. So this is not the solution. And if you will put x is equals to 2 and y is equals to 3 in the same equation, this is also not satisfied. So case 1 and case 3 is ruled out because these values of x and y are not satisfying our given matrix equation. So this 2x is 2 and y is 2 is the only value of x and y which, if substituted in the given matrix equation, they will be satisfying. When you will put x is equals to 2, y is equals to 2 in the matrix lying at the left hand side and the matrix lying at the right hand side, you will get same matrix in both left as well as right hand side. So this is how you can determine the values of x and y using the concept of equality of two matrices. Let us take this another case. Express the following relation, this, in the form of a single matrix where I is a 2 by 2 identity matrix. Okay, good. What does it mean? Here they have given you a matrix equation, right? This matrix is multiplied with 5. This matrix is multiplied by minus 3 by 2. And plus I is an identity matrix of order 2 by 2. Simplify this equation, you will get a single matrix. This is what you want to do here. Express the following relation, this in the form of a single matrix. I is a matrix of order 2 by 2 means what? 2 by 2 means I is equals to, say, matrix like this, 1, 0, 0, and 1, right? I is I2, or you can, I2 means matrix of order 2 by 2. I2 is written as like this. So in place of I, write down this matrix and simplify it. You will get a single matrix that will be the required answer. I think it's a very simple case. See, this can be written as 5, 2, 3, 4, 1. This matrix minus 4. This is minus 4. 3 by 2, 4, 3, 6, 5 plus I, right? First, transfer this equation in a complete matrix equation. Complete matrix equation means put the value of I here first in the equation. So what you will get? 5 of 2, 3 minus 4 and 1 minus 3 by 2 of 4, 3, 6, 5. And what is I? I can be taken as 1, 0, 0, 1, right? Now, multiply this matrix by 5. What you will get? 5 to the 10, 5 3 the 15, 5 4 the minus 20, 5 1 the 5, right? This is the scalar multiplication. Minus, multiply this matrix by 3 by 2. So 3 by 2 into 4, 2 to the 4, that is 6. 3 by 2 into 6, 2 3 the 6, 3 3 the 9. This is 3 into 3, 9 by 2, right? And this is 5 into 3, that is 15 by 2. Clear? Plus this will remain as it is, 1, 0, 0, 1. Now what we will do now? Either take this minus this first or this plus this first, then subtract from this. It's up to you. For example, this is 10, 15, minus 20 and 5. Keep the first matrix as it is. Minus. Take the sum of these two. So 6 plus 1, this is 7. 9 plus 0, this is 9. Clear? Right? Look at very carefully. 6 plus 1, this is 7. And 9 plus 1, this is 10. Now 9 upon 2 plus 0, right? 9 upon 2 plus 0, it will remain 9 upon 2. And 15 by 2 plus 1, see, 15 by 2 plus 1, what you will get? 15 plus 2 by 2, that is 17 by 2. So we write here as 17 by 2, right? We came to here, see? This is our given matrix equation. We replace the matrix I by 1, 0, 0, 1 Then we have multiplied this matrix by 5 and this matrix by 3 by 2. We are getting matrix this and this. Now add these two matrices, you will get this matrix minus this matrix. Now take the difference of these two. So naturally the difference of these two is what? See, I may write it here. 10 minus 7, that is 3. Minus 20 minus 9, you will get here minus 29, right? 15 minus 9 by 2. Oh, 15 minus 9 by 2. So what you will get here? 15 to the 30 minus 9 by 2. What you will get? 21. You will get here 21 by 2. 5 minus 17 by 2. So 5 minus 17 by 2. What you will get? 5 to the 10 minus 17 by 2. So this is minus 7 by 2. Minus 7 by 2. The same matrix we will obtain from here, right? So this is in fact a matrix equation. And we will have to represent a matrix equation into a single matrix, right? Let us take this case. This is a different case of the diagonal matrix. We have all studied about diagonal matrix. Diagonal matrix is that matrix whose diagonal elements are non-zero and different from 1 and 0 elsewhere, right? A diagonal matrix is a matrix whose diagonal elements are non-zero and different from 1 and 0 elsewhere. Different from 1 means if they are 1, the matrix will convert to the identity matrix. For example, let us write a matrix, diagonal matrix first. Say 3, 0, 0, 0, 5, 0, 0, 7. This is in fact a diagonal matrix because its diagonal elements are different from 0, non-zero as well as different from 1. Look at this. If they all are 1, 1, 1, then it will convert to the identity matrix. That is why the imposition of different from 1 is mandatory, right? So this is a diagonal matrix. We can write this as DAIG diag and like this 3, 5, 7. So this matrix can also be written in short form like this, right? Now we can proceed for the question. Okay, understand? The diagonal matrix means if a square matrix whose diagonal elements are non-zero and also different from 1 is called a diagonal matrix. See, let A is equals to diagonal of 2, 4, 5. B is equals to diagonal of 3, minus 1 and 2. So see, what is the meaning of this? Diagonal of 2, 4, 5 means what? Let us see first, as I have just mentioned before you, diagonal of 2, 4, 5. Diagonal of 2, 4, 5. It means they are the diagonal elements. This can be written as 2, 0, 0, 0, 4, 0, 0, 0 and 5, right? This matrix and this matrix both are same. Understand? These are the two ways in which a diagonal matrix can also be represented. So A is equals to diagonal of this, B is equals to diagonal of this. Then find A plus B. Means we want to calculate the sum of two diagonal matrices. Then A minus B, naturally the difference of two diagonal elements. Then 3A plus 5B. 3A means the scalar multiplication of a matrix A with 3. We call it as 3A. And 5B means the scalar multiplication of B with 5. We call it as 5B. So first find out 3A, then find out 5B, and then add up these two matrices to get 3A plus 5B, right? Let us see, it's very simple case actually. we have, let A is equals to this, right? Diagonal of 2, 4, 5. See, this matrix can be written as 2, 0, 0, 0, 4, 5, 0, 0, 5. They are the diagonal elements, and the rest elements are always 0. Similarly, B is this 3 minus 1 and 2. So 3, 0, 0, 0 minus 1, 0, 0, 0, 2. So 3 minus 1 and 2, they are the diagonal elements. And you know how the two matrices are added? We simply add the two matrices if they are of the same order. Of course, the order of A and B both are same. They both are of order 3 by 3. Therefore, we can always find out the sum, A plus B. And the sum means by adding the corresponding elements of A as well as B. See this? A plus B is what? This is your A and this is your B. So A plus B means 2 plus 3, that is 5. 0 plus 0, that is 0. See, 2 plus 3, that is 5, right? 0 plus 0, that is 0. This 0 plus 0, that is 0. What is 0? All the diagonal elements except the diagonal elements, everything is 0. So 0 plus 0 is 0. So whenever we are adding two diagonal elements, their diagonal elements are simply added. It means 2 plus 3 is 5, 4 plus 3 is 7, 5 plus 2 is 7. So we will get a matrix 5, 0, 0, 0, 3, 0, 0, 0, 7. It means it can be written as diagonal of 5, 3, 7. Likewise, when we are subtracting two diagonal matrices, their diagonal elements must be subtracted because all the other elements are always 0. So we will get the diagonal matrix minus 1, 5, and 3. Likewise, to find out 3A, multiply the matrix A with 3. A contains only diagonal elements. So multiply all the diagonal elements by 3, you will get 3A. 5B means multiply all the diagonal elements of B by 5, you will get 5B, and then finally add 3A plus 5B to get the required sum of these two matrices. It will again be a diagonal matrix. Sum and difference of two diagonal matrices is also a diagonal matrix. Finally, let us take this example also. This is somehow different question. If A is equals to 1, 0, 2, 2, 3, 4, 3, 2, 1. This is a matrix A. Find the matrix B such that A plus B is diagonal matrix. Oh, this is somehow new question, and it needs some calculations also, right? Okay, no problem. What is given here? We have given here A, right? Find out the matrix B such that the sum of A and B should be equals to a, this should be a diagonal matrix. Are you getting the point? If A and B are any two matrices, A is known, B is not known. A and B are added. So what should be the matrix B so that the sum of A and B must give you a diagonal matrix? This is the question which you want to solve. Actually, this question have many ways to find out its solution, I think, but it needs a lot of calculations. So I use the approach which is having in fact the least calculation, right? I will try to find out the solution of this question by not any standard method, but only my intuition, so that the calculations may be as small as we can. Let us see. To make A is this, so what is given? We have given the matrix this. We want to calculate the matrix B. We have taken B as a matrix this, right? Why B has this? We want to calculate A plus B. The order of A is 3 by 3. and A is added to B. So addition of two matrices is possible only if they are of the same order. So it shows that the order of B must be 3 by 3. That is why we have taken this matrix B11, B12, B13, B21, B22, and B23, B31, B32, and B33. This is the matrix which we have taken, right? What we want to do? We want to do that A plus B must be a diagonal matrix, right? What should be B? B is this. So how we can make this B as diagonal? So I have used only my intuition. See, to make A plus B a diagonal matrix, the off-diagonal elements of the matrix B must be negative of the off-diagonal elements of A. What does it mean? A plus B is a diagonal matrix. So A plus B is diagonal matrix means only a matrix which will contain only diagonal elements, right? A plus B is diagonal means A plus B, the matrix obtained after getting A plus B will contain only diagonal matrix, zero elsewhere, right? This is what we want to do. So to make A plus B a diagonal matrix, the off-diagonal elements of the matrix B, off-diagonal element means the elements other than diagonal are known as off-diagonal. Off-diagonal elements of matrix B must be negative of the off-diagonal elements of A. Off-diagonal elements, as I have told you, off-diagonal elements means the elements which are different from diagonal. They are known as off-diagonal element. So if A plus B, you want to have a diagonal matrix, then off-diagonal element means all the elements of the matrix B other than diagonal must be negative of all the elements of the matrix A other than diagonal. Clear? Are you getting the point? In other words, you can say that the elements of the matrix B which are non-diagonal, they should be negative of elements of A which are non-diagonal. Clear? Non-diagonal means what? See, this is the diagonal. Non-diagonal means B11, B13, B23, B21, B31, and B32. They are the elements which are called off-diagonal. Right? Off-diagonal simply means the elements other than diagonal. Right? So what does it mean? It means all the elements of B other than diagonal should be negative of all the elements of A other than diagonal. Is it clear? See, what does it mean? B12, say I am taking B12. B12 should be equals to minus A12. It does it mean? B12 should be negative of minus times of A12. B13 should be negative of A of 13. Right? B23 should be negative of A23. What is left? B21 should be equals to minus times A21. B31 should be equals to minus times A31. And B32 should be equals to minus times A32. This is what I want to say. The off-diagonal elements of the matrix B must be negative of off-diagonal elements of the matrix A. Right? The elements of the matrix B other than diagonal elements should be negative of the elements of A other than diagonal. This is what I want to say. So B11 must be equals to minus times A12, right? What is the value of A12 here? See, this is A11, A12 is 0. So B12 is equals to minus 0. This will be equals to 0. Clear? This is how we calculate this. Now B13 should be equals to minus A13. A11, A12, A13. A13 is 2. So it should be equals to minus 2, right? Because the elements of B which are off diagonal should be negative of the elements of A which are off diagonal. Now B21 is here 2. Sorry, B21 is equals to minus times A21. A21 is 2. So B21 is minus 2. Third. B23 is equals to minus A23 and A23 is A21, A22, A23 is 4. So it should be minus 4. B31 is equals to minus A31. A31 is 3. So it should be minus 3. And finally, B32 is equals to minus A32. A32 is equals to A32 is 2. So it should be equals to minus 2. Right? The diagonal elements of B can be taken as 0 for simplicity. I have taken the diagonal elements of B 0 only for the simplicity to make the calculations easy or to find out the solution of this question. Otherwise, we have also some way out, some methods to find out the solution of this question, but the calculations will become very complicated. Therefore, the matrix B, put the values here, is equals to this. See, the diagonal elements are 0. We have taken the diagonal elements of B is 0. See, if B is this, then what is the value of A plus B? A plus B, this is A, this is B, A plus B. A plus B is coming out to be 1, 3, 1. It's a diagonal matrix, right? So this is how we can find a matrix B if it is added to a matrix A, such that the sum of A plus B is diagonal matrix. So students, thank you very much. I think I should stop this session here. So thank you very much for your patience learning. Thank you.